So unit number 6 is about the transient stability. So we are particularly focused on transient stability only. So in this particular unit, we are going to focus on the transient stability and the various methods with which we can analyze the power system in terms of the stability. So first let us know what are the outcomes of this unit. So outcomes, let us see what are the outcomes of this unit. So at the end of this unit, you all will be able to build the algorithm to solve the transient stability using modified Euler method and Runge-Kutta 4 method. So both these methods are the numerical methods which you have already learned in the semester 4 of electrical engineering program. So with the help of this particular techniques, numerical techniques rather, that is modified Euler method and the Runge-Kutta 4 method, we are going to build the algorithm to solve the transient stability problem using these two techniques, that is the modified Euler method and the Runge-Kutta 4 method. So to begin with, let us draw the chart of the power system stability, because we should know what is exactly the power system stability, and with the stable system what exactly do we mean. So we have to know this, and with the knowledge of this we can actually classify the power system stability in various parts. So when we talk about the power system stability can be divided in major two types. Let us see what are the two types. So power system stability, this can be divided broadly in two parts. What are the two parts? Let us see. First part will be small signal analysis. So in this small signal analysis, we deal with the two types of the stability, that is the steady state stability and the second one is dynamic stability. And the other part, that is the large signal analysis. So in large signal analysis, we have the transient stability. So this is the broad classification of the power system stability. If we define the power system stability, the stability of a system is broadly defined as the property of the system that enables it to remain in equilibrium under normal operating conditions and to regain an acceptable state of equilibrium after being subjected to disturbances. Because we know that whenever there will be system, we cannot consider that system will be perfectly balanced all the time. There can be disturbances, and in this condition of the disturbances, if our power system is operating under the normal operating condition, it regains an acceptable state of equilibrium after it is subjected to the disturbances. Then we will say that the system is stable. So power system stability is a term which is applied to the AC electrical power system. So we will see the definition of the power system stability. So I will write here definition. So just now what we have said that we will write in short form, we will define it as to remain in the state of equilibrium, to remain in the state of equilibrium, to remain in the state of equilibrium when under the normal operating condition. To remain in the state of equilibrium under normal operating condition and to regain an acceptable state of equilibrium after being subjected to a disturbance. So this is the definition of the power system stability. So it will remain under state of equilibrium when during the normal operating condition, but whenever it is subjected to any type of disturbance, then it should regain an acceptable state of equilibrium after being subjected to the disturbance. So this is what we understand by the power system stability. Then when we talk about its analysis or this concept, so power system stability is it is a term which is applied to AC electrical systems. This we should remember. So this is applied only to the AC electrical power system. Okay. So as our unit is focused on the transient stability, we will directly switch to the topic of the transient stability. So we will directly move to the transient stability part, and in the transient stability, I have already in the last lecture I have already instructed all of you that we will require the help of the swing equation. So have you all learned the swing equation? Have you recollected the swing equation from electrical power system too? Because it will be used here in this particular unit. We will be using the transient stability terms with respect to the swing equation which we have derived in the electrical power system too. So I am not going to derive it here once again. I am directly writing the swing equation, and then we shall write the equations related to the modeling of the transient stability equations. So I hope you remember the swing equation. I will directly write it from swing equation. So this equation we have already derived in the 7th semester electrical power system 2. So please refer it from there. So from swing equation, what do we have? From swing equation, we have m d square delta by dt square is equal to Pm minus Pe, that is equal to Pa, where Pm is the mechanical power or we call it as a shaft power, which is basically the input. So in the power plant, the shaft power is the input power. Then the generator converts this input power to the output electrical power. So PE is the electrical power, which is generally the output. And the difference between the PM and PE is actually PA. So when we talk about PA is the accelerated power, and M, of course, we know the moment of inertia, so that I am not going to write here. So from this particular equation, let me give this equation. Suppose this is equation number 1. So from where this equation has come? This equation has come from the electrical power system to the derivation of the swing equation. So I'm not going to derive here the equation again. It's already derived in electrical power system 2. You can take it help from there. So I will just write here the reference. The reference is EPS2 derivation. So you can go back in your copies and check the derivation. From there you can note the derivation of the swing equation and you can approach to this particular equation, that is m d square delta by dt square is equal to Pm minus Pe, that is equal to Pa. So what is delta here? Delta is the angular displacement of the rotor. Angular displacement of rotor. So this equation is very important for us. Why this is important? Because this equation gives us, let me write here, equation 1. What does 1 gives us? 1 gives us the rotor dynamics. What do we mean by rotor dynamics? Rotor dynamics of the synchronous machine. So where our rotor will be positioned, the angular displacement with respect to the time and the shaft input power, output power, electrical power and the accelerating power. So this equation is therefore very important, and this is the first point, that from this equation 1 we can get the rotor dynamics. And the second point is that this is a second order non-linear differential equation. So second order non-linear differential equation. So if we will be able to solve this equation, then we can get the solution of this particular swing equation, and with the help of that we can conclude towards the rotor dynamics. So when we solve these equations, or when we take the case of these equations and when we try to solve these equations, then we will get the uh, P delta curve, right? So we will get the P delta curve, and this P delta curve is very important for us in case of the transient stability. Also, with this equation, when we solve this, we get the position of the delta with respect to the time. So that is important for us with respect to this unit. So इस यूनिट में हमें वो इम्पोर्टेंट चीजें हैं. So I will directly start with the swing curve. So I will write here the heading swing curve. So let me draw the swing curve. So here this will be y-axis. Here we will have delta, and here in the x-axis we will have, say, time. This will be our reference line, and let's say we start with an initial delta 0 here. This will be delta 0, then initial swing, so in this way we have drawn our swing curve. So if this line keeps on increasing, then our system will be unstable. At this peak, we have d delta by dt is equal to 0. And if our curves keeps on in the downward direction, then we call it as a stable region. So this is the swing curve. What is the peculiarities of the swing curves? Let us understand. So characteristics of swing curve. So the swing curve, the first characteristic is that it gives the variation of variation in delta with respect to time. So this is the first characteristics of the swing curve. Swing curve actually indicates that the rotor shall either accelerate or decelerate when there exists an imbalance between the mechanical input and the electrical power output. So this is the second point. So the swing equation will give us whether the rotor is either accelerate or decelerate when there is imbalance in PM and PE. Due to this, the rotor may run above or below the synchronous speed. So this dash line, you can see this is the synchronous speed. So our rotor may go above or it may come below this synchronous speed, which indicates the system instability. So if our graph is coming downwards, then we call it as a stable system, like from the delta 0, that is the initial swing. So this is the initial swing. So after this initial swing, if our curve goes on increasing, then we say that our system has lost the synchronism and it has gone into the unstable state. When we call it as after the first peak, if the graph is going in the downward direction, then we say that our system is stable. So this is what we understand from the graph of the delta and t. So this graph is obtained once we solve the swing equation. So once we solve the swing equation, then only we will be between delta and t. So the swing equation which we have seen just now, we will again see the equation. So this is our swing equation. M d square delta by dt square is equal to Pm minus Pe, that is equal to Pe. So once we solve this equation, then we will get the variation of delta with respect to time. So once we get the plots, that is the graph, then with the help of this particular graph, we can come to a conclusion that whether our system is going to become stable or it will fall out of synchronism and it will go in the unstable region. So this is what we can understand from the, or rather we can conclude from the swing curve. So swing curve can be prepared only after the solution of the swing equation. So swing equation we have already learned in the EPS 2 of 7th semester, and now in this, with the help of this swing equation, we have come to the swing curve. So swing curve, what does it denotes? Swing curve denotes us that our whether our system will become stable or it will be unstable. It depends on the position of the rotor with respect to the time. So that's why it's important for us to solve this particular swing equation and to know the position of the stability with respect to the large disturbances. Why large disturbances? Because we are now dealing with the transient stability, and the definition of the transient stability itself states about the large disturbances. So small disturbances can be considered in the small signal analysis, like in the very first slide we have seen the classification of the stability. So in the small signal analysis we have steady state stability and we have dynamic stability. Whereas in the large signal analysis, that means the large disturbances, we have the transient stability. So that's why transient stability will be subjected when we have the large disturbances in our system. यहाँ तक समझा सभी को? Please reply on the chat box. Then we will start with the parts which are given in this particular unit of caps. Because till here you all have learnt in your EPS 2. Now the next portion that we will be learning, this is the part of the semester 8 computer application in power system. So please reply first. समझा सभी को यहाँ तक? Only 2 students? What about others? बाकी के स्टूडेंट्स को नहीं समझा क्या? Yes, what about other students? बाकी के स्टूडेंट्स क्या कर रहे हैं? बाकी के सारे स्टूडेंट्स क्लास में अटेंशन है या नहीं है? one or two students are only replying, बाकी के सारे students बस बैठे हैं. Okay. So now let us start with the topics of this particular semester. So numerical solution of swing equation. So there are various techniques with the help of which we can solve this swing equation. I will write one by one here what are the various techniques. So first technique is point by point method. Second is modified Euler's method. Third is Rangaputta 4 method. And fourth is Milne's method. So out of this four, we have in our syllabus modified Euler's method and Rangaputta 4 method. So these two methods are to be learned by us in the this particular unit number 6, that is related to the transient stability. Okay, so that's why I have asked all of you yesterday, please go through modified Euler method, which you have already learned in 4th semester of electrical engineering program. So have you all gone through the modified Euler method? Because we will be starting with the modified Euler method, as these two methods are to be learned by us. So we will be starting with the modified Euler method. So have you all gone through the modified Euler method from semester 4? Because we would like to have the algorithm of the modified Euler method. So if we take the modified Euler method, then what are the various steps that we have to follow in order to get the solution of the swing equation? The swing equation just now we have seen, that is m p d square del, sorry not p, m d square delta by dt square is equal to pm minus pe, that is equal to pa. So this equation we have to solve. This equation will be solved various methods. Those are point by point method, modified Euler's method, Rangaputta 4 method, Milne's model. So out of this we are going to learn two methods, that is modified Euler's method and Rangaputta 4 method. These two are there in our syllabus, so we have to learn these two methods. Then only we will be able to complete our syllabus of unit number 6. So have you all gone through the modified Euler method of 4th semester? नहीं किया है तो ईमानदारी से बता दो, कोई प्रॉब्लम नहीं, because then I will have to go through the basic steps of the modified Euler method or the algorithm of the modified Euler method. Otherwise you won't understand the solution of this power system problem. अगर प्रोसीजर पता है तो ठीक है, कोई प्रॉब्लम नहीं. प्रोसीजर नहीं पता है तो प्रोसीजर पहले मुझे बताना पड़ेगा और उसके बाद हमें पावर सिस्टम का प्रॉब्लम लेना पड़ेगा. यू कैन जस्ट इमेजिन कि फिर कितना समय लगेगा हमें हमारे पावर सिस्टम से रिलेटेड प्रॉब्लम को सॉल्व करने के लिए. That's why I have requested you to go through the 4th semester syllabus and just brush up your contents that you have with you related to the modified Euler's method and Rangaputta 4 method. Okay, so who will tell me what is the procedure? Tejaswini. Tejaswini, you have replied. So can
Yes, sir.
you start?
Hello.
Can you start with the procedure? Dx by dt is equal to fx of x y t, because we are going to equate it with reference to time. And the second equation, suppose it is dy by dt is equal to fx x comma y comma t again. So these are the two simultaneous differential equations, let's say. Then we have to start from the initial values. Suppose I say that the initial values are, let's say, x0, y0 and t0. So these are the beginning of the time step, and step size is suppose h. Suppose I say step size is h. What do we mean by this step size? Step size का meaning है कि स्टेप साइज का मीनिंग क्या है कि सपोज अगर टाइम है तो टाइम को हमें कितने इंटरवल से बढ़ाना है, लाइक 0.5 से बढ़ाना है, 1 से बढ़ाना है, 1.5 से बढ़ाना है. वी डोंट नो एज ऑफ नाउ कि टाइम स्टेप साइज क्या है. सो आई विल टेक द स्टेप साइज एज h. So when we solve this equation with respect to the initial values, तो initial values से जब हम इसे solve करते हैं, तो let's say initial values जो है हमारे, let dx is equal to fx of x0, y0 and t0, and suppose this is dx by dt at 0. So suppose ये 0 पोजीशन पे वैल्यूज है, और सिमिलरली y के लिए suppose हमने लिया dy is equal to sorry, in the first equation we have to mention y, है ना. यहाँ पे x हो गया तो ये हमें y लेना पड़ेगा, because this is the second equation. So this we have to take with the help of y. So this should be y. So please make the correction here. यहाँ पर y होना चाहिए. Then I will write the second equation in this way: fy x0 y0 t0, and this is suppose dy by dt at 0. So suppose these are the two equations we have differentiated, and x0 y0 t0 को लेकर हमने इस तरीके का जो इक्वेशन है वो लिखा हुआ है, राइट. नाउ वी हैव टू गिव द प्रेडिक्शन. हमें कुछ प्रेडिक्ट करना पड़ेगा x और y के लिए. तो सपोज द प्रेडिक्टेड वैल्यूज जो है, सपोज मैं यहाँ लिखता हूँ. सो एक्स पी सपोज प्रिडिक्टेड है इसीलिए मैंने p दिया, इज इक्वल टू x0 प्लस dx h. What is h? H is the step time, so step interval, sorry. So this is 1, and for y, let me write here yp is equal to y0 plus dyh. So these are the predicted values. x और y के ये predicted values हैं. Okay. Now with the prediction, what we can write, let us see. dx predicted is equal to dx by dt predicted, that is equal to fx, predicted values of x, predicted value of y, and suppose t1. Now we have started with the time intervals. Similarly, dy predicted is equal to dy by dt predicted, that is equal to fy x p y p and t1. Now द करेक्टेड वैल्यूज। सो अभी जो करेक्टेड वैल्यूज हमें मिलेंगे वो कैसे मिलेंगे? करेक्टेड वैल्यूज कुछ इस तरीके से मिलेंगे, x1 इज इक्वल टू x0 प्लस dx plus dx predicted divided by 2, and this will be multiplied by the time interval. Similarly y1 जो है वो हमें मिलेगा y0 plus dy plus dy predicted divided by 2 multiplied by h. That was the concept of the modified Euler method. So how this concept will be used by us to solve the transient stability problem, ये हमारे सिलेबस में है। So आज जो हमने ये बेसिक्स पढ़ा, ये क्यों पढ़ा सबको ध्यान में आया? क्योंकि मॉडिफाइड यूलर मेथड में भी आप लोग भूल गए होंगे, तो ये मैंने एक बहुत ही शॉर्ट में डिस्क्राइब करके आप लोगों को समझाया कि मॉडिफाइड यूलर मेथड कैसे यूज होता है, और यही अल्गोरिदम यूज करके हमें मॉडिफाइड यूलर मेथड अप्लाई करना है टू सॉल्व द ट्रांजिएंट स्टेबिलिटी प्रॉब्लम. Is it clear everyone? So tomorrow we are going to take a very important part of our unit. बहुत important part हम complete करेंगे हमारे इस यूनिट का. ये